Hello guys, today we start the chapter surface development and the problem number is 3, that is in your screen you can see here the problem, that is a right circular cone of base diameter 50 mm and axis 60 mm long is resting vertically on HP. It is cut by a sectional plane sectional plane inclined at 40 degree to HP and bisect the axis of the cone. Draw the development of the lateral surface. So first of all we have to draw the top view and then we draw the front view from the top view. Suppose here is our reference line. This is our reference line and we draw here the cone. So top view means the top view of a cone, that is a circle, and the cone is vertically on HP, resting on HP. So suppose the diameter, you take 50 mm diameter and axis length means height of the cone, that is 60 mm. So we take 30 mm as a 25 mm as a radius. So 25 mm, suppose this is 25 mm is as a radius, and draw the top view of the cone, that is in your screen here. So this is the center, this is the center here, and this is the top view of a cone, this is apex and this is the base. Now draw projection from here. You have to draw the projection from here. Suppose this is the projection line. First of all, we divide this top view into 12 equal divisions. Divide the top view into 12 equal divisions. This one is the vertical one, and at an angle 30 degree. If we divide this 360 degree, then each angle is how much? That is 30 degree. We divide this into 6. So we divide this top view, that is a circle, into 12 equal divisions, and each division I count here, that is, suppose this is A, this is B, C, D, E, F, G, H, I, J, K and L. Understand? So we divide this into. Now this is the axis. This is the axis. If we draw a projection line, this is the axis of the cone, central axis, and we draw the apex here. Apex is, this is the base of the cone, Suppose this is the from here to here, that is 60 millimeter, that is given here. You can see the and axis length is how much, that is 60 millimeter. So this is the apex top point. Now join these two. So this is the front view. This is the front view of the cone. This is the front view of this cone. You see here, this is the front view, and now draw the projection line of this up to the front view from the top view. I am tilting this. Draw projection line of this division up to the front view. Understand? So we draw projection line from each and every divisions up to the front view, means up to the reference line. This is our reference line. So this is the HP. So extend it. Now here you can see it is cut by a section plane inclined at 40 degree to HP and bisect the axis of the cone. So the axis length is 60. So at a half, from the half portion, suppose this is 30 millimeter. From here to here this is 30, and from top that is also 30 millimeter. Now we cut this by a section plane that is 40 degree angle with HP. Suppose this is 40 degree angle cut by a cutting plane. Understand? So this is the cutting plane. This is the cutting plane which is at an angle 40 degree. 40 degree from HP means this angle is how much? This is 40 degree with HP, means this angle is 40 degree. Now this is the apex. This is O dashed, apex O dashed. Here in the front view this is O, this is center O, and join this projection line up to the apex. Now join this projection line similarly join this line also to the apex, this line also with the apex, and this line also with the apex or apex or vertex of the cone. And these are the generator. These are the generator, that is I am marking here. This is A dashed, B and L. Here is B dashed and L dashed. This point is C and K. So this is C dashed and K dashed. This point, that is D and J, means D dashed and J dashed. And this point is C and this is E and I. This point is becomes E dashed and I dashed. And this point is F and H, F dashed, H dashed, and this point is G dashed. So this is the position. Now draw, this is our cutting plane. So from the cutting plane we have to mark all the points of this projection. Suppose this is the cutting plane, bisect the projection line or generator O dashed A dashed in the point A1, in the point 1 or 1 dash, suppose 1 dashed. Similarly, this is OB, and in the front view O dashed B dashed is this line. This line, the cutting plane cuts this projection line at where, that is 2 dashed. Similarly, this is COC 3 dashed, OD 4 dashed. Similarly, OE line is the 5 dashed. Similarly, F, this point is 6 dashed, and G, that is 7 dashed. Understand? 7 dash. Similarly, this projection line OH, the cutting plane cuts, that is 8 dash at the back side, 8 dashed, and similarly this one is 9 dashed. Similarly, this one is 10 dashed, this one is 11 dashed, and this one is 12 dashed. Understand? So 12 dashed. Now this is the 12 dash. Now you can see here, here this line 7 dashed, the cutting point of OG means this line. So draw a projection line from 8 dashed up to this point, that is up to what? Up to this point. So this point is a which point? That is the OG. This was the OG, cuts the cutting plane cuts the OG here. Means we project a line, that is the problem number point number 7. Understand? Similarly, 1 we draw a projection line, means OA this one. So draw a projection line from here which touches at what point this is. So this is the point number 1. Similarly, 2 and 12. 2 and 12 means this is 2 and 12 cutting the point OB and OL, means we draw a projection line from 2 and A, OB, which touches the point where OB and OL, just like this. This is B, means OB2 and OL, that is 12. Now again, the cutting plane cut the projection line division OC and OK at the point 3 dash and 11 dash. So we draw a projection line here up to the point this OG and 3 and 11 from here 3 means OG and OC, OK and OC. So this is the point. OC point touches here, so this is the point number 3, and this is the point number 11. And here the 4 line, for the 4 line, that is, we can't got it from this top projection line, 4 and 10. Now draw the projection line from here, cutting point, this FH. Draw a projection line here, FH, F and H, that is here, and H and F, this point, this is the point number 6, and this is the point number 8. Similarly, another cutting point, that is 5 and 9. So 5 and 9, draw the projection line from here. We got the point, this point, and we got another point here, that is this point. So this point is 5 and this point, that is 6, 7. This point 7, sorry, this point 7, and we got the 2 points, that is 5 and what is the line, this point. Then we got another point 5, and actually this is in this point, this is 9. So actually this is not here, so draw the 4 is here. You can draw a straight line and make it up to 4 point here, and just rotate this point. We can got the point 4. Similarly 10, rotate this point. This is 10. This is 8, and we can got, actually this is the point we can get here. This is the point 9, and this is 10. So join all these lines. We can got the top cutting plane here, just like this. This is the top portion. If we remove this portion, then this is the section plane. If we see it from the top, this is the section plane. If we cut out, we can get a section plane from the top here. Now if we develop this cone, this cutting cone, then a formula is there, that is called subtended angle. Subtended angle, SUBTENDED angle. Subtended angle equals to what? That is equals to small r by capital R into 360 degree. So here we have to calculate that what should be the R, what should be the height, that we have to calculate. Take a measurement from the subtended angle. So angle you have to calculate. R is where? R is this is the radius. Suppose this is, if this is a cone, then this is the height, that is capital R, and the base radius is small r. This is small r. So you have to measure. Small r is 30 and capital R you have to calculate, because the height you know this is 30, then you can easily measure this generator. This is generator or R. Here it is R. So one formula is there for subtended angle. What do you mean by subtended angle? Means if we develop this portion, then we got the subtended angle. Suppose this is, you have to calculate, and from R you know it rho, so you have to calculate the angle, how much it would be. Now take the radius, take the length of the generator. Suppose this is the length of the generator. This is the length of the generator. So you have to draw here just like this. If we develop it, and sorry, I can found the center of this arc. Suppose this is the center, this is the center. Now draw just an arc, draw an arc. This is our center, and mark any line here. Mark a line here. From here, take this angle, whatever it comes, take this angle. This is called subtended angle. Suppose this is how much? This is theta, equals to theta. So this is, you take an angle theta from here, and suppose up to this point this is theta, and join this. So if we develop the lateral surface of this cone, then we got this total distance. Now you divide this angle into 12 equal division. Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Suppose this is a theta. So 1 division, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 division. Suppose up to this point this is the division number 12, and this angle is theta. This is called subtended angle. Suppose up to this point this angle is how much? This is theta. Understand? This angle is theta. Suppose this angle is theta. So now join this division. Join all this division to the center. Suppose this is and join this. So this is A, OA, OB, OC, OD line, this line, DE, OE, OF, G, H, I, J, K, L and M. Understand? Sorry, ij kill and another it comes back to meet at A, OA. Now take this length from O1, OA, the cutting plane cuts it at O1. So O1, take the distance O1. So O1 at OA means this is 1, this is here also it is 1, so it is the position 1 of the position of the point 1, and here is also it is 1. Similarly, take the length from the O, 2 and 12. So it is the distance 2 and 12 from here. You can get here 2 and 12. So this is the from B and C line, B and L line. This is OB and OL is here, and the distance is how much from O2 dash and O12 dash. So B and L, that is this distance. This is this portion, and OL, this portion. So this is the position of the point. This is 2, and this point is 2, and this point is how much? What? That is 12. This is 1 position of the point, 1 here, 2 is at this position, and 12 is in this position. Similarly, we got the point OC 3 and 11, that is from OC and OK. So 3 and 11, from here you take this point here, 3 and 11 in OC and OK. So OC this is OC, this is 3, and OK means here this is OK, so OK this one, so this is 11. So this point is 3 and this point is 11. So this is 3 and this point is 11. Similarly, take the point O and 4, 4 and 10. Take the point from here, 4 and 10, 4 and 10 here. 4 is at the OD and 10 is at OJ. 4 and 10. This point is 10 and this point is 4. Similarly, 5 and 9. 5 and 9 is OE and OE and OI. OE and OI. 5 and 10 from here. 5 and 10 from here. Take the point, this distance here. So from O it is, this is the point number 5 and this is the point number 9. 9. So this is the point number 10. This is the point number 9 and this is the point number 5. Now similarly take 6 and 8. Similarly this point 6 and 8 from here, 6 and 8 from here. Similarly here 6 and 8, 6 and this point is 8, and take this point O7. 7 means it is OG. So this is OG. This is the point number 7. Now you join all these two with a curve So and join this. This is the development of the this is the development of the cone which is cut by a cutting plane. So this is the lateral portion of the development of this cone.